In this section, we're going to discuss further what reference variables are. The purpose of a reference variable is to tell us where to go in memory to find the data we want. Therefore, a reference variable is not the data we're looking for. It is the location of where that data is. An analogy here is an index entry in the back of the book. We go to the back of the book, look up the term we care about. When we find it, it has a page number or list of page numbers that tell us where to go to find information on that particular topic. The index entry isn't the information we want. It's just a pointer to where we can find it. A reference variable begins its life uninitialized. We must initialize it with some value. We can initialize this variable with the literal value null, which means it points nowhere. It refers to no object. That literal value can be tested for. In this code example, we have a circle class, a variable called C, a reference variable to an object of that circle class, and we assign it initially the literal value null, saying that it refers to no circle object at all. Then, to give it an initial value other than null, we say C assign new circle 2.5. The new operator goes out, reads the circle class description, determines how much memory to obtain, gets it, and then runs or invokes the circle constructor, passing the argument 2.5 to it, and that's undoubtedly the radius. So the radius of the circle object would be initialized to 2.5. And then the location in memory of that object is assigned to the reference variable C. Now C will refer to that piece of memory that represents a circle object, and it's going to have a radius of 2.5 units. A primitive variable is an expression that yields its value directly, as in double x assign y. A copy of y's value is remembered in the variable x. When we refer to x, we get a copy of that value. A reference variable, in contrast, only states where to find object data. It is not the data. To access data from an object, we have to do a double hop. That is, we need to have the reference variable itself to say where to go. And once we get there, we need the second hop, which is the method as here getRadius, to tell us what to do. The reference variable tells us where to go. The member on the right-hand side of the dot says what to do. Takes the two pieces of information. The dot or period is called the member access operator. It says, C object, I want you to access the getRadius method and do whatever that code says. It will return a radius in this case and assign that value to the double variable x. One might wonder, why didn't we just assign the double variable x directly to the object C's radius value? There's a problem with doing that. Ideally, no class makes its data members public. That is, no client code, no external code can see the data members directly. The data members are defined by specifying the private keyword. That means only the class can see those data members. Some reasons are that client code can inadvertently or maliciously modify the data, and that's not good class design. Secondly, the class may store data in an unfamiliar format and do calculations on that format to return it in the expected way. For example, if we were remembering distance, we may remember it in metric units and then ask how many feet is that, and do a conversion and return feet. But since the data is stored directly as metric units, we wouldn't want the client to see that because they might misconstrue meters for feet and make computation errors. Here's an example of age. We wouldn't want our client to have a negative age. If the data member were public, it could be changed to an invalid value like -1. If we hide our data inside the class using the private keyword, only then the age member can be accessed through methods, and those methods can validate the data before changing it to ensure that it is legitimate.